the lady told me that the recording has started, so I'll go ahead and share my screen. All right, so hopefully you should see my screen. And at this point, I don't see you anymore in Blue Jeans. So if you want to talk, please unmute yourself. All right, here we go. So this is a talk about ARA, but this is about callback plugins in general. So let's get started. So who am I? I'm David Morosamard. I'm an SRE for OpenShift at Red Hat, so a site reliability engineer. What I do, the core of my work is around CI/CD. So it's about putting code to production at scale. So we need to test before things merge into branches. We need to test after it merges into the branches. We need to deploy those. We need to upgrade those. And so CI/CD, I do a lot of that, and a lot of that involves Ansible. I'm the author of ARA, which we'll talk about in this presentation, but also I've written a bunch of Ansible things. I'm also a drive-by contributor to Ansible. The reason why I mention drive-by is because I'm not a full-time contributor to Ansible. It's just whenever I see something wrong and I know that I can fix it, I fix it, and then I say, a pull request. So I have a few of those, but otherwise I'm not, actively involved in Ansible. Before being an SRE for OpenShift, I was at Red Hat before for 3 years. I was managing and operating the upstream OpenStack infrastructure. So OpenStack has hundreds of projects for which they need CI/CD infrastructure and stuff. So I was part of the team that helped manage this infrastructure. And then Red Hat has our sponsors a community project called RDO, which I was also a member of. RDO is basically the distribution of OpenStack, so you can do like yum install OpenStack, and that works. Before that, I know it should have been like the other way around. I haven't had a bunch of time to set this up. But before joining Red Hat, about 3 years back, I was 10 years at iWeb, which was later acquired by Internet, over which I spent, a bunch of, I occupied a variety of roles ranging from technical support to leadership positions. So that was a pretty cool gig. So there is a short agenda, but hopefully it should cover plenty of topics. We have some time for a Q&A at the end. I haven't timed this presentation, so hopefully it should satisfy your thirst for Ansible things. So before we begin, let me tell you a little bit about the life before ARA, which is right now, right? At least for you. So this is what you've probably used Ansible before, so you know what this looks like. So the problem with Ansible when you're in playbooks is, or especially at scale, is that you have so many tasks across so many hosts, and then there's something in there that didn't work, right? So what do? You log to a file, or this particular log was exposed through a web browser, so makes my browser cry at night, and I need to do like Control F, and the browser goes like, hey, this way too many lines. So, this is what the life before ARA looks like. So the problem that we're actually trying to solve with ARA is um, being able to tell what, when, and where things happen. So what other solutions are there? You could always run Ansible. I know people who like have muscle memories on their fingers that type like Ansible playbook minus VB for having a minimum amount of verbosity in their Ansible playbook runs. There's other callbacks like human log. You might have heard about human log, which expands uh, things like commands into proper like uh, what's it called, like pretty printed JSON and stuff like that. There's YAML. So really, all of those callbacks, um, what they end up doing is actually printing more lines or more output. So it doesn't solve the problem of trying to find, um, what went wrong, or at least finding it easily. And I have a quick, there's a quick website here. I'll put the link on the meetup page or something. But it's someone that's actually found this through Reddit. There's an Ansible subreddit, so by all means check it out. It's a pretty active community, helpful too. So anyway, the author of this page shared this project on Reddit, and it's pretty cool. So Ansible, it turns out that Ansible has a bunch of callbacks, right? I won't go into all of those in detail, but I was talking about YAML earlier. So if I look at YAML, when I click here, it shows what the YAML callback does. So let me try and go back here. So this is what the YAML callback does. So that's not the standard default, or the default would be here actually. So this is what it would look like by default. So that's not awesome. So there's YAML, there's debug, there's a couple of other. This debug is actually this is what human log looked like, but I think it's been upstreamed as and known as debug for now. So anyway, there's a couple of callbacks like that you can. They're bundled in Ansible, so you don't need to install anything. They're there. You just need to tell Ansible to use those. So really, again, this gives you more context or more information about the Ansible playbook run, but it doesn't make it easier to find what happened on which host and so on. So the spoiler is the solution is ARA, right? And I'm not here to sell you anything. This is free and open, and it's a free and open source project. This isn't an official Red Hat project. It's something that I created to help me in my work actually. So this is just an example of a patch that was sent for a project in the OpenStack community. So they were running Ansible super verbose VBV, like very very verbose. Kidding. So anyway, since they started using ARA, they didn't need be verbose anymore. Just like the regular output was fine, which made the console much more easier to search. But also ARA was enabling them to find what they needed quickly. So I'll tell you a little bit about what's ARA and then how it works in the context of callback plugins. So ARA Records Ansible, it's another recursive acronym. So what ARA does is in a nutshell, is it records Ansible playbook runs and makes the recorded data available and intuitive for users and systems. So ARA doesn't parse like the output of your playbook runs, for example. It really saves it into a database and provides a web interface and a command line interface to browse that data. And the next major release that I'm working on will actually ship an API so that you can query this database in a in a programmatic way, basically. So what does installing and using ARA look like? You've probably installed Ansible with pip before, pip install ARA. So ARA ships a little module called ara.setup. Ara.setup actually doesn't do anything. It's just a helper that helps you print commands or paths. Oh man. Right. So this allows you to print some of those commands that Ansible expects, right? The reason why we created this is because this path will change, depending on which distro you install on. So if you install it on CentOS, it's going to be here. If you install it on Ubuntu, it's going to be elsewhere. If you install it on, I don't know, Fedora, it might be elsewhere, or even Python 2 versus Python 3, or inside a virtual environment, or all of that. So this command will print whatever path is the right one. So it removes all the logic of having to find, oh man, where did I install ARA? You don't need to use it, but it's there. So this is just a quick command that basically, it doesn't. So when I type this, it doesn't run the exports. It just prints the commands to do it. And then by doing a source of this, it actually runs the exports. You don't need to do it that way, but this is just an easy way to get started. So then that's it. All I need to do is to tell Ansible, there's a callback here that I want you to load. I run my playbook as usual. And then if I do an ARA playbook list, which is the CLI interface for ARA, it tells me, okay, I have saved this playbook here. And then I can, there's a built-in web server, so you don't need to have a complex setup to host a web interface. You can run this, locally on your laptop if you want to. And this is the great thing about ARA, is that by default, that's all you need to do, really. There's nothing else. You do pip install ARA, you tell Ansible to use it, and you're done. You don't need, the default database is SQLite, but it doesn't prevent you from using MySQL or PostgreSQL. I've even heard of a user that is using Oracle. Apparently that works. I don't know. So it relies on SQL Alchemy for the SQL bindings. So as long as you have the right SQL Alchemy drivers installed, it should work. So yeah, that's that. So what does it look like in practice? So this is the web interface of ARA. I'm not going to go into too many details here because we're gonna look at it in the live demo a little bit later. But this is this is what you're presented with when you load the web interface. So you have the playbooks that ran at a glance, the status of what was the status of the playbook runs, and then it provides you with the details of what host, plays, files, and tasks were involved in that playbook. And then there's a search feature, so it allows you to search either by keyword or status, by role, stuff like that. So this is, again, everything could run from my laptop if I wanted to. So enough of that. So how does this thing actually work? So it's easy. You just draw ARA, the ARA logo, and then you're done. No, I'm just kidding. So I told you about callbacks earlier, right? So this is what an Ansible playbook output might look like if you have the default callback. And then if you run the same playbook again, and then your stuff is item components, you might see this instead, right? It's not changed because the resources are already there. But then if I enable one of the bundled callbacks in Ansible, profile tasks is one of them that I like to enable by default. It changes the output to look like this instead. So it's going to show you how much time each task took. And then at the end of the playbook, it's going to have like a top 10. This is a bad example because there's just one task. But there would be like a top 10 or something like that of the tasks that took the most time. So it doesn't add a lot of lines to the playbook run. So it's kind of lightweight and has a lot of value in my opinion. So this is one of the callbacks that Ansible ships by default. So how do these actually work? The callbacks are really, really easy, and I highly recommend you to look into them if you want to do things with Ansible. I mean, if they're not modules or action plugins, of course. But seriously, Ansible callback plugins are super powerful. So what it looks like in practice is this. So you have, out of the box in Ansible, you have a class that you can extend. And the class provides these methods. So these methods will fire when a certain thing happens, right? So v2 on any would fire every time there's an event. So this event can be playbook on start, playbook on task start, playbook on play start, playbook on stats, or runner unfailed. It's on any basically, right? But then here you have runner unfailed. So runner unfailed, you might want to have I don't know. Maybe you want to have a message on Slack if there's a failure. You could do this here. It's Python code, so whatever you do in this, as long as it's Python and the necessary dependencies are installed, you can do whatever you want. So maybe you want, so this v2 playbook on stats is the last callback hook that is fired. There's more of those, but for the best interest of the screen real estate here, this is what I cherry picked. But playbook on stats is the last one that fires, and this is where you'll have access to how many tasks were changed, how many tasks were failed, and so on and so forth. So maybe you want to do something every time a playbook ends. You could do this. You could write some code here, and that's how you would do it. Right. So this is what I was telling you that ARA leveraged the callback plugin interface. So this is what it looks like. We're extending callback base. We have some boilerplate here, and then once the playbook starts, this is a little bit what the code looks like in ARA. We create a database entry for the playbook itself with the version of Ansible and the path to the plugin file. So see here, v2 on playbook on start, you have a playbook object here. And this is provided by Ansible. So you have a bunch of stuff in here. And I've had a bunch of fun reverse engineering it because I had no clue how it worked at first. But basically, in the playbook object here, see here I have file name, which is just one of the many objects that you have access to. But you have access to a bunch of things. The result here is the same. There's a bunch of stuff in here. Here, a task play, it's the same thing. You'll have a bunch, all the information related to the task or the play are available there. So this is how ARA saves everything to a database. Basically, ARA has this method called log task, which will take the entire result and says okay, so the status is okay, but then grabs everything else and it basically saves everything to a database and then provides the interface and the CLI to browse those. So it's really clean and it's really lightweight because there's no parsing involved. So it's actually really, really simple. Slightly related, ARA provides Ansible modules too. I'm not going to go into the details here because we wanted to talk about callback plugins. So there's an area here in ARA that has its records. So it's just an arbitrary key value store, our key value, a key value store for saving any kind of data that you might want. So an example that someone asked about a while back was how the user stored his playbooks in Git, which is not unheard of. Yeah, you wanted to save the Git commit hash for that playbook run. So this is how you would do it. You would get the version of the playbooks and then use the ARA record module to save this under the key Git version, and then you get commit hash here. Moving towards the live demo, just a little bit of context first. I told you that I worked a lot in the OpenStack community before. The OpenStack there's a lot of OpenStack projects leveraging Ansible in different ways, whether that's for managing the OpenStack infrastructure itself or installing, I don't know if you've heard about OpenStack before, but it has like sort of a reputation about being hard to install. So there's a lot of there's 3 or 4 projects that leverage Ansible to deploy and operate OpenStack. So, but there's also day two operations. So once you have deployed OpenStack, there's a lot of ways to help you get going with Ansible. I'm going to focus on the last bit here, which is about CI, or continuous integration. So it turns out that testing like hundreds of projects, integration testing for more than I think it's 1,300 projects now, or maybe more than that. So it turns out it's pretty complicated. So the OpenStack community created this thing called Zool. It's generic now. It used to be something that required OpenStack. It was pretty specific to the community and its projects. But it's grown into its own project now. But a lot of users like BMW, Juniper. I'm trying to think of names that I can actually say. But anyway, there's a lot of big users of Zool. Why I'm talking about Zool is because Zool uses Ansible. So you probably know Jenkins, right? So Zool is somewhat like Jenkins. It will run jobs, but it's not just that. And I could talk about Zool for 30 minutes, just Zool itself, because it's really great. But I'm gonna try to stay on time. There are video presentations of Zool if you would like, that were done at a conference recently. I would highly encourage you to see those if you're interested. So anyway, back to Zool. Zool for the OpenStack community runs upwards of 300,000 jobs per month. In aggregate, it leverages Ansible to run those jobs, and the jobs are actually expressed as Ansible playbooks. So that's over 100 million. That's way too many. It's too many zeros. Over 9,000 million playbooks per month. And it's just running at this monstrous scale. So it's pretty fun project that I like to highlight. So Zool uses ARA, so I'm going to show you a little bit what it looks like in practice. So I need to do this. So Zool looks like this. There's a couple of pipelines here. I'm gonna clear the filter. So there's a lot of jobs here running. So if I click here, this is a change set, and this is not super relevant because it's Garrett and it's a code review for OpenStack, and this is not what we're interested in. But I found a nice example earlier, which is actually an Ansible project within the OpenStack community, OpenStack Ansible. It's pretty great if you want to set up OpenStack with Ansible. So there's someone here who submitted a patch here to, do something with ZFS, I suppose. I don't know. I don't judge. So every time someone sends a patch to an OpenStack project, there's a bunch of jobs that run here, right? So there was an example here where a job failed. So this one job failed in 1 hour and 9 minutes. So as a developer or the contributor of this patch, I go here, I click here, and I have access to all the logs for that job. So if I click here, I might have the typical Ansible playbook output. Let's count how many lines is here. Might do something like this. There's more than 1,000 matches, which is somewhat expected. But anyway, there's a lot of stuff in here, right? So if you want to find what went wrong, it kind of sucks. So there's another report here, and this is what I'm greeted with. So let us walk through the UI here for a second. So I have a permanent link to the playbook report. So if I want to share just one report, this is so yeah. Let me backtrack a little bit. So this is 5 playbooks for a single job. The OpenStack use case is very CI specific, not specific, but focused around CI. So they have a bunch of playbooks that run for a single job, and it's self-contained in a single database. So actually, I can download the database just by going to the database thing. So this is just one database. Some users of ARA actually aggregate runs instead. So they'll have one long-lived instance that serves, that has a bunch of reports over many days or many months, however they like. So this is just the report for one job. So going back to what the UI looks like, I have the permanent link here. I have the status at a glance. So the playbook completed with errors here. This one says it was interrupted, but it's kind of a race condition because the ARA report is generated by Ansible itself. So this one is never shown as finished. Anyway. So the date at which the playbook started, the playbook file, and the full path. If I click on the playbook file, it's gonna show me what Ansible version it ran with, what time it ran, and the actual playbook as it read. So this is kind of important because over time, as your playbooks change, this will stay intact, right? It's history, it's a log. So if things start failing, you can go back and see, hey, last week, what this what did this thing look like, right? I have how much time this particular playbook took. I have the parameters for the playbook. So this is somewhat what you would pass to the Ansible playbook command. So the arguments and the flags. So the inventory, the forks, the extra vars, which are not saved by default because people tend to put stuff like passwords and stuff in there. But you can blacklist like certain parameters so that they're not saved physically. You have hosts. So yeah, I'm gonna go here. So hosts here, you see how many tasks of each status you would have. You have the host. So during this playbook, we had we gathered the facts. So we have access to a quick view of what the host facts look like. But I can also click on the host and see all the facts as as they were collected for this particular playbook. So they're not updated in time. This is what the host facts looked when they were gathered physically. So then the plays, there's nothing great here to show in this example, but you would see the name of the play, when it started, when it ended, and what was the duration. Files. So there's nothing much interesting here, but if I expand this one, I'm going to see all the files that were involved as part of the playbook. And again, I can click on each of those files and see what exactly they looked like when they ran. And then you have tasks, which is the interesting part. So I'm going to go here and see. So there's the name of the task, the host against which it ran, the action or the module. Elapsed is just like an ordering of the tasks. Basically, if I go here, it might make more sense. So it's just ordered by from beginning to end. If I go here, this is the end of the playbook. The duration, so how much time each task took, and I can like sort this, so I could go and sort by duration to see which task took the longest. And then I have the status of each task, and then I click here. I see what is basically what you would have seen if you would have ran the playbook in console, but pretty printed and just for this one task. So if I go here, this task failed, but I could, if I have sorry, a bunch of tasks, I can actually search or filter them, right? So see, I searched for changed here, and all the change tasks are here. Same thing for failed. If I could search for failed, oops, and it shows me the result. But I could, how there's this prefix for roles. I could search for this, and it would find all the tasks for this role. So, it's a pretty basic search, but there's regular expressions and stuff like that. So you can search for localhost, and would pick up the tasks that run just for this host. Or I could search for Ubuntu Xenial, and it would only show for that. There's also the concept of tags, of which I don't think we have any tags here. But you could, if there's tags on each task, you can see them. So going back to this failed task here, because this is what's interesting to us. If I click here, this is what failed. And this is not a super great example because it's a bash script, so there's a bunch of output actually. But I chose this example explicitly because what the bash script ends up running is Ansible things. So yeah, if I click here on the command, I see it opens up the file that this task was contained in, and it tells me where this task was in this playbook file. So it allows me to easily and quickly find, what's the context of this failure? Like, where did it fail exactly, right? So this is where it failed. So I told you that this ends up using Ansible. So the OpenStack Ansible project actually uses ARA themselves also. So this is like from Zool's perspective. But there's also the perspective of the Ansible that ran to deploy the OpenStack stuff. So there's a bunch of more things here, right? So many more tasks and stuff like that. So if I click here and I search for failed, I have, the real failure here. So verify stuff monitors are up. So I click here. Okay, and this is where the thing failed. Okay, sure. And then I click here, and it tells me, oh, it's because the Ansible port isn't. Okay, so that's it. I can go back and fix my thing. And then if I want to share this with someone, I can just click here, and it's going to give me this permanent link, and I can like copy paste this and show someone that, hey, this is where the thing failed. So that's pretty much what ARA looks like, or at least the interesting parts of the web interface. There are records. Let me show you real quick a record. Wrong link. There was a patch earlier that someone sent to ARA here. So the great thing about this is that it gets a little bit confusing because ARA is an OpenStack community project, which is tested by Zool, and Zool uses ARA, and the integration tests, like when someone sends a patch to ARA, it uses Zool, which runs ARA, but I want to test ARA, so anyway, that's really confusing. So I have the report here that was built as part of my integration test, but this is the part that I want to show you in records, just some examples. So the records has the concept of formatting. So it's pretty basic, but it allows you to print JSON or DICs or URLs. This does not come out of the box, but this is basically the output of the playbook run itself, in its raw format. So this is something that I saved. So here there's a dictionary in the list. So yeah, that's it, I think. All right, let's go back to the slides here, and I guess that's it. I'm gonna stop the screen recording, or not the screen recording, but the screen sharing, and then we can go to questions if we have any.
What's the command line interface look like?
Sure. Okay. Let me. I don't have. Okay. If you give me a second, I'm gonna go ahead and share my screen again. So let me see. I'm gonna. Okay, I'm gonna need to run. Oh yeah, run test. I'm gonna just run some tests locally to generate a test database, so I can show you what the CLI looks like. The CLI is pretty basic, and one important thing is that what I'm showing you right now is the 0.x version of ARA. So let me go here. So there's 0.x, which is what I'm referring to here. There's a new, and which is basically an entire rewrite of ARA, which is 1.0, which is not yet ready for release, but it's getting there. So it's going to be a little bit different in 1.0 is what I mean, but that's not super relevant. I'll let the tests run here. Okay, this should be enough. Let me interrupt it if I can. Okay, great. So I'm gonna go with this. This is the path is temp our test logs. All right. Temp our test logs Ansible SQL. All right. So this is what I'm gonna zoom in a little bit so you can see better perhaps. So I can do ARA help of course, but or ARA help playbook list. So the CLI allows you to print the data into different formats, or print only the stuff that you care about. So it's not an API, but there's people that have written things that wrap over this feature. So for example, if I run YAML, it's gonna instead of printing like in a pretty table, it's gonna print out in YAML, and then I can use this output into whatever script that I might have, or I can do JSON as well, right? So I can do also, and I want to find the tasks for this one. I would run ARA task list. No, hang on. Or this playbook. And then I have all the tasks for this playbook. And again, I can, run. Yeah, another thing is ARA saves the duration of each task. So I don't want to fork into another direction. This reminds me of a great use case that a project has. So they actually use ARA to, they use ARA for reporting, but they use the data like duration and stuff like that to feed into InfluxDB. Then they have graphs with Grafana. So if I go, what is it? Here, then yeah, so this is data that was fed from Ansible to ARA and then ARA to InfluxDB. So ARA doesn't like natively support exporting to InfluxDB, but they wrote a wrapper around it. I think it leverages the CLI. Like they dump everything in JSON and then they only take the stuff that they care about. Did that answer your question?
Yeah.
Cool. Any other questions?
How much data does ARA generate, like for Zool? Like how many gigs of data do you generate a day of just ARA stuff versus?
So this is a tricky question, because of the scale that Zool actually runs at, we needed a way to make things as efficient as possible, basically. There is I can let me share my screen again. I should probably leave there. All right, there we go. So in the docs here, there's advanced use cases. So this is what we created especially for Zool, that other projects are also using now. So by default, ARA saves everything into a SQLite database, and it's actually pretty small, the database itself, I mean. So I went into, so yeah, let me go backtrack a little bit. So before this existed, the only way, or there was two ways of serving the reports. The first one was hosting the actual web application over, USGI or stuff like that. But you could also, and you can still today use HTML exports. So you can do ARA generate HTML and then the path, and then it's going to generate a bunch of HTML files. But it turns out that at scale, this is not really great because it's a lot of tiny little files. Like for this one, it will generate like an HTML file for each one of those results. So it's not awesome, right? So the example here, for this amount of tasks and results and hosts and that, in the HTML, that was 27 megs gzip. But this HTML, when it's not rendered in the database, it's only 5.6 megs before gzipping. So the reason why the database is still is very manageable is because of the way that ARA stores the files in the database. So ARA does a little bit like Git in the sense that it will only store one unique copy of the file. So there's a hashing that happens, and then we only ever store one copy of each file once. So if you run the same playbook with the same files 20 times, there's only going to be one copy of the file, and it's actually compressed inside the database. So since it's text, everything that Ansible runs is YAML. Everything compresses very well. So the overhead is instead on the CPU rather than disk. In 1.0, we're still using that approach, but there is interest in other ways of serving that data over the API. So since it's, for example, it's kind of tricky to have a stateless JavaScript only interface to read data from the API. So some people would like ARA to expose a JSON file instead of a database, or things like that. So I realize that this does not really answer your question, but all things considered, the fact that Zool keeps every job isolated from each other and then eventually expires them. So that's the thing, right? So we only keep logs for around 31 days or so. So the OpenStack log server is around, I don't know, let's go and check. Last time I looked, yeah, it runs on 14 terabytes for the logs. So, it's still a lot of logs, but that's not just our reports because they retrieve logs for everything. They'll retrieve like systemd logs and OpenStack project logs and config files and whatnot. So, all things considered, at the scale that this runs, it's pretty manageable. I hope that somewhat answered your question.
Yeah, that was good. Thank you.
Cool. Any other questions?
No, I think that pretty much answers the questions for right now.
So the slides are on, here, if you want to browse them. There's a website for ARA here. It's open source. It's GPL. You can look at the code here. We're on IRC. There's a bunch of people on Freenode. And I forgot to put a Slack here, but there's a bunch of people on Slack too, and IRC and Slack are bridged, so people can chat with each other. It's great. So yeah, feel free to come and ask us questions there. Well, it was great talking to you guys.
Yeah, thanks for the presentation.
Yep. I'll stop the recording now.